Greetings everyone, and welcome to this video in my lecture series on binary, octal, and hexadecimal numbers. In this video, we will convert non-integer decimals to other bases, looking at the particular case of numbers greater than 1. So as our example, we're going to convert 19.96875 to octal. Now, we've previously looked at converting just integer numbers to octal. We've also looked at converting non-integer numbers that are less than 1 to octal, and those have two different methods of doing so. The integer part has the repeated division method, and the non-integer part has the repeated multiplication part. And it's a grand tradition in math and science, engineering, and technology to, if you have a new problem, to try to reduce it to a previously solved problem. So what we're going to do is we're going to break this into two parts. We're going to convert the 19 to octal using our previous method, and we're going to convert the decimal 0.96875 to octal using that other method. So, the integer part. We're going to convert 19 to octal using the method of repeated multiplication. Just going to draw a little thing like this, where we write 19 and we divide it repeatedly by the base. We're looking at octal here, so it's base 8, and we're going to break the break that up into 2 bits. 8 goes into 19 twice, with 3 left over. Now, if you're doing this on a calculator, the way you can do it is you take 19 and divide it by 8. 19 divided by 8 is 2.375. So take the 2 and write it in the Q column, and take the 0.375, multiply it back by the 8, and put the result, which is 3, in the remainder column. You should never have any fractional or decimal entries in either of these columns. Then take the quotient, the 2, and write it over here to the left. That's the thing that we're going to divide by 8 again. And if you divide 2 by 8, you get 0 with 2 left over. Remember that once the Q column goes to 0, you can stop. Then we highlight the remainder column, and we can write our answer starting from the bottom and moving up. So we get that the integer part, which is 19 base 10, is equal to 23 base 8. And that makes sense if you think about it, because the number 23 base 8 means that there are 2 complete copies of the base, so 2 times 8 plus 3 left over. 2 times 8 is 16, plus 3 gives 19, which is the number that we started with. So that's kind of reassuring. Now we're going to do the non-integer part. We want to convert the 0.96875 to octal, and we're going to use the method of repeated multiplication. We take the 0.96875 and we multiply it by 8, and we break it up into the two parts, the integer part and the non-integer part. 0.96875 times 8 gives 7.75. So I'm going to write that as 7 plus 0.75. The non-integer part gets repeated below, and we repeatedly multiply that by 8. So you get 0.75 multiplied by 8 gives 6, plus 0 left over, so that it gives only an integer and there's no non-integer part. And once this is 0, you can stop. And what we end up looking at is the integer part here, and the direction we're interested in is going down. And so we can say then that the non-integer part (0.96875) is equal to 0. Remember that 0.96875 is a number that's less than 1, so in octal it'll also be less than 1. So to the right of the octal point, or the radix point, then we write the 7 and the 6 from our column, our integer column that I've highlighted in blue. And I have to remember that that's base 8. And so to wrap that up, our conclusion, we put those two together. 19.96875 base 10. Well, we haven't bothered to say the base because it's our default. Now the 19 gave us 23. The 0.96875 gave us 0.76. And putting those together, we get that 19.96875 base 10 is 23.76 base 8. I hope that helped. Thank you all for watching, and I'll see you in the next video.